Welcome back to another stats video. This one is on calculating or estimating the correlation coefficient. Let me explain that. Alright, so we've learned a little bit here about what correlation is and how to interpret it and how to compare different correlations to each other. But what if a question asks us to calculate or estimate the correlation coefficient? Now, the reason we use the word estimating here is because we have an imperfect method of finding the coefficient of correlation. Now remember, those nerdy words, correlation coefficient, they just mean the R value, which represents the strength of the correlation between two variables. So to calculate it or estimate it, what am I going to do? Well, I have to be given a scatter plot graph to be able to calculate. You won't have to build one on your own on an exam. So you'll be given one and you're going to draw a box around the points that you're given. This sounds a little bit crazy, but watch how it works. Now here's a scatter plot graph that I've been given, and I'm going to draw a rectangle around the points that form the trend. And this might sound silly, but be careful drawing your rectangle. It's not always as easy as you might think. A little trick here, start with one long side of the rectangle, follow the trend on the long side, and then draw the other long line parallel to that. Then you can close in the ends with the short sides of the rectangle at 90-degree corners. Be really careful to try and do this properly. And that rectangle needs to be drawn as close to those dots in the trend as you possibly can. And once I draw that rectangle, I've got to measure those side lengths. The short side and the long side should match up when I measure if I've done a proper rectangle. If they don't match up, you can take the average or the mean of the two short sides for that measurement and the average of the two long sides for that measurement. And once I have my measurements, I'm going to plug them into this formula. Now the formula looks a little bit strange or different from what we're used to seeing, but I'll explain the different parts. Out front of the brackets, you have a positive and a negative sign. That's there for you to choose whether the trend on your graph is a positive slope or a negative slope. So observe those dots and figure out if the trend is sloping upwards or downwards. A positive slope in that trend means you choose the positive sign in front of the brackets. A negative slope means you choose the negative sign. Inside the bracket, that first number is always 1, and you're always going to subtract from it the short side over the long side measurements of the rectangle you just drew. So here's how it looks in my case with the numbers filled in. So you can see the answer that I got here, and don't forget the negative sign in the answer. That indicates that the correlation between the two variables is negative. And now if I had to, I could locate that number, that correlation coefficient on my scale to figure out how strong or how weak this correlation is. And that's pretty much it for estimating the correlation coefficient. But here's a couple of important reminders before we see another example. First, you have to draw a proper rectangle, and you have to draw it as tight as you can to the dots that form the trend. Second, you may have heard talk of something called an outlier. An outlier is going to be very obvious. What it means is it's a dot that doesn't really follow the trend on the graph, but it's going to be very obvious if you're looking at an outlier or if you're not. And the last thing is to just measure carefully and use the formula properly. Remember to choose the positive or negative sign based on a positive or negative sloping trend, and then be careful filling in those numbers and doing your math properly. So let's see another example, this time with an outlier.